In 9.6, we're going to work on solving quadratic equations by using the quadratic formula. In 9.5, we worked on solving by completing the square. And these two methods are methods to use when it's not possible to factor a quadratic. These will work for every single quadratic function that there is. And the key vocabulary here is the quadratic formula, and many of you may already know that, but let's take a look at it. The quadratic formula is that the value of x will be equal to the opposite of b plus or minus the square root of b squared minus 4ac, all divided by 2a. And in this case, they're claiming that b squared minus 4ac has to be greater than or equal to 0. That's not true. If we want to find solutions in the realm of real numbers, that's true. But as I've previously explained to you, there is a set of imaginary numbers that you'll be working with in your future, and that's what happens when b squared minus 4ac is less than or equal to 0. The solutions will be in that set of numbers. Okay, so when we go ahead and work with solving using these two methods, completing the square of the quadratic formula, a lot of it depends on, is there a leading coefficient and what is the value of b, and you'll develop your own personal preferences for when you would want to use which. Again, both of them work for all quadratic functions, so you can use them interchangeably. So if I want to go ahead and solve a quadratic equation, I need to make sure that I remember that I have to find the values of a, b, and c. So in this case, a is equal to 4, b is equal to -1, and c is equal to -18. And then I can go ahead and plug into x is equal to the opposite of b, so that's the opposite of -1 is 1, plus or minus the square root of b squared, which is 1, minus 4 times a, which is 4, times c, which is -18. And all of that is over 2 times a, which is 4. Now, one of the problems with the quadratic formula is it's got some features that are problematic for students frequently. And one of them is caused by this: I've got a binomial in my numerator. I've got this plus or minus something else. So what I want to do is I'm going to distribute the division to protect myself from making a mistake. So 2 times 4 is 8. So this is going to be 1 over 8 plus or minus the square root of 1 minus 4 times -14. So the nice part is it's minus a minus. That's going to become plus. And this will be 1 plus 16 times 18. So I'm going to go ahead and pull this out. 16 times 18 plus 1 is 289. So it's going to be root 289 over 8. And I would want to go through and figure out, hey, is 289 a perfect square? I don't know. Let's see. Yeah, it is. It's the square of 17. All right, so that's going to be 17 over 8. So I'll have 1 over 8 plus or minus 17 over 8. And when I do plus, it's going to be 18 over 8, which is going to be 9/4. And when I subtract, it's going to be -16 over 8, which is -2. And these are my solutions. Okay, so remember, the difficulties that students typically have is starting to simplify without distributing the division first. If you simply break this into two fractions at the beginning, then that will protect you from making that mistake. And the other is in properly simplifying the radical. Here's an application problem. So for the period of time from 1971 to 2001, the number of Y films produced in the world can be modeled by this function, where X is the number of years since 1971. In what year were 4,200 films produced? So Y is the number of films. So I know that if I take 4,200 and I plug it in for Y, that's going to equal 10x squared minus 94x plus 3,900. And if I subtract 4,200 from either side, I'll get 10x squared minus 94x minus 300. Okay, and this is certainly a case where you might look at this and go, oh, I really don't want to complete the square. That's not going to be any fun. It might make sense at this point to go with the quadratic formula. So I'm going to take the opposite of b. The opposite of negative 94 is 94, plus or minus the square root of 94 squared. That's going to be a big number. Minus 4 times a, which is 10, times c, which is negative 300. And this whole thing, excuse me, that was a mistake, is over 2 times a, which is 10. So it's all going to be over 20. And true to my word, I'm going to go ahead and say 94 over 20 plus or minus this other thing. So let's figure out what that is. I know that this is going to be 4 times 300. I know, again, it's minus a minus, so this is going to become plus. 4 times 300 is 1,200 times 10 is 12,000. So I'm going to square 94 and add 12,000. So 94 squared plus 12,000 equals 2836. Okay, so I'm going to have root 2836 all over 20. So let's hope that that's a perfect square or something. That would be really nice, but it's not. 144.36, wait, 144.37. So we're just going to call that 144 because we're talking about numbers of films, or in number of years. So I have 94 plus or minus 144.37. So 144.37 over 20. So let's go ahead and add 94 to that. And then divide it by 20. And it's basically 12 years, right? So we have 11.91. We're going to use 12 years for that. So it's approximately 12 years. Now to answer the question, 12 years from 1971, that would be 1983. And as a summary to our concepts of solving quadratic functions, we've learned a number of methods. We've learned factoring, graphing, finding square roots, completing the square, and using the quadratic formula. So when would you want to use them? Well, I want to factor it when it's easy and I can find the factored version of the quadratic quickly. I would want to do that. I would like to use graphing when most appropriate, especially if I'm using a tool. And mostly appropriate means when approximate solutions are adequate, meaning I don't have to have an exact number because, there's no guarantee that my x-intercepts are going to work out to be whole numbers, which are the easiest solutions to find by graphing. Finding square roots, I'm going to find square roots when I can isolate a perfect square on one side or the other. And that sort of is combined here with completing the square. Completing the square in the quadratic formula can be used for any quadratic functions. And I'm most likely to use completing the square when the leading coefficient is 1, or when b is an even number, or if the leading coefficient is not 1, where it's easily factorable out of, where the a value is easily factored out of the b value. Otherwise, you're going to create some pretty interesting fractions, and not all of us really want to work with fractions, so you can avoid that then by moving on to the quadratic formula. But of course, the quadratic formula is a fraction, so you're still going to be working with fractions. So generally, the quadratic formula is my last choice. I like it if the numbers are large and awkward, like in that last example.